Hi, we are team AirLight for the ESE 5160 subject, and my name is Suraj Sri Balakrishna Marthi.
My name is Akhil.
So our project here is aimed at solving and identifying the gaseous presence in a house, and if any harmful gas is present in the house, we are taking a necessary action to help the user of the house to take corrective measures and save his life. So there have been many cases in the world where people have passed away and are sustaining fatal injuries due to gaseous presence in their houses, and corrective measures could not be taken in time. So this triggered our interest in this area, and we wanted to provide a solution through the Internet of Things perspective. So as per this scenario, what's happening is when the air quality in the house degrades, the door of this model starts opening up and creates a air ventilation system that helps the user to take immediate measures and save his life. So now we can give you a demo about this project through the model that we can see here. So we have completely made this model through laser cutting, and we have designed this in SolidWorks. This is the 3D printed design of the casework of the PCBA, which has cutouts for all the wires that come in and out of the PCBA. This is the gear that also has been 3D printed, along with this rack and pinion system, which is connected to the acrylic door connected over here. So this rack and pinion system converts the radial motion of this servo motor into linear motion to move the door sideways. And this is the PCB that we have mounted inside the 3D printed casework. We have a offboard air quality sensor attached to one of the walls of the house, and we have a RGB LED attached to one of the walls of the house, which will be actuated upon reduction of ambient light inside the house. So that is the basic idea about this project. And now this is the PCB.
So this is the actual PCB, which resembles like a shape of an house, so which indicates our AirLight project. So if you see this PCB very closely, we have an like onboard ambient light sensor on the right top, and we have other components like microcontroller, we have an SD card module, and we have a power module, and we are using a 3v3 buck, so which will be with the 3.3 volts will be used to power all the sensors, actuators, and working of other components. And this is our node-red module. So you can see there we are checking three different values. One is the light intensity value, which is taken from the ambient light sensor, and we will be getting the lux value. And there are two other values like TVOC, the total volatile organic compound, and carbon dioxide level inside the house. You can see the values are changing continuously, so it is a real-time value will be displayed for the user on the dashboard. And we even have an threshold set, so whenever these values are below the threshold level, the light will be glowing and the user will be able to view all those things. And on the right side we have couple of buttons provisioning for the user to control various actuators from his dashboard. So now I can show the working of both the actuators. So initially I am showing with LED, and now I am showing the actuation of motor. The opening and closing of motor. So now we will start the demo.
So now I am first plugging in the roof of the house as designed for the project. So this is the complete design, and you can also observe that the system is completely being powered by a lithium-ion battery, and no other power supplies are being provided. All are disconnected out. So now this is working standalone and does not require any additional power supply. Now we will start the light intensity value. Currently the current lux value shown in this device is at 24. It is at 38 currently. So now if you look at the demo, yeah. So now so we are using a towel to simulate the light reduction level. So when I've covered the device, the RGB LED has turned on, indicating that the intensity level inside the house is below a certain value. Now as soon as I remove the towel from on the house, the intensity value increases, and the RGB LED has turned off, which indicates that the light intensity is back to normal. Now we will be demonstrating the total volatile organic compound and the carbon dioxide levels using a matchbox for now, showing that the gaseous presence inside the house will cause the door of the house to open up to facilitate air circulation. Now you can slowly observe that the air quality levels of the house starts degrading as the gaseous presence is. So if you can see, the values are slowly increasing as the gas increases inside the house. Now we will take up the values little higher than 2000 parts per million for the carbon dioxide levels. So if you can see, the carbon dioxide levels have gone beyond 2300, and hence the door of this house is automatically opened up. Now the values of these levels are too high, so I am showing this through the by removing the gas from this house. Now you can see that the levels have slowly reduced for the house, and if you can observe here, automatically the door will start to close. The door has automatically closed now, indicating that the levels inside the house are at a nominal value, as you can see here. Now we will be connecting the serial connections to show the over there firmware update.
Initial version.
The version is initially seen as 1.0.0. Now we will be running the over there firmware update. So I am clicking this button now. I clicked on this button, and you can see that the file is being downloaded. Now this is going to take a little bit of time. File download is complete. It has been written into the SD card. So now the device is flashed with the new firmware. Now we'll check the version of this again. Now the version is seen as 2.0.0, which is the new version. And now we can check that the functionality still remains. We will do it through the actuation LED. When we click on this, we can see that the LED glowed. And when we click on the motor button, we can see that the motor has opened, door has opened. So this is the overall functionality and the demo of our project AirLight. Thank you.